All right, this is the next lesson, lesson number 38, the expected value of a random variable. So in the last lesson, we talked about the probability distributions of a random variable, and this is related to that. So the expected value or mean of a random variable can be interpreted as the average value the random variable takes on across a large number of experiments. So it's kind of exactly what you think it is. The expected value is the value that you would expect to occur at the experiment. It's the average, basically. Suppose that x is a discrete random variable that takes on these values, and each value is assigned a probability. Then we find the expected value. This is a Greek letter pronounced mu, I guess you would say, mu, is all of the x values times their respective probabilities all added up together. So that is how we find the expected value. So we had this example in our previous lesson. Now we want to use this table to find the expected value of the experiment. So to do that, the expected value here, I take each of my x values and multiply them by their respective probabilities. And I add them all up together. 0 times 0.2 plus 2 times 0.3 plus 4 times 0.3 plus 8 times 0.1. So this is negative 0.2 plus 0 plus 0.6 plus 1.2 plus 0.8. And if we add all of these together, negative 0.2 plus 0.6 plus 1.2 plus 0.8, I get 2.4. So this means that the expected value, or kind of the average or mean of this experiment, is 2.4. The reason that we don't just average these numbers together and then divide them by the number of values we have is because that does not account for their distributions. So for example, I'm more likely to get a 4 than I am a negative 2, and so this adding their values and their probabilities together helps us to account for the difference in the probability of getting each one. Alright, so let's do another example. This one is for the pet example. The following probability distribution for the random variable x was created from a national survey based on the responses from households on the number of pets in the house. So to find the expected value of this, I take each of the x values and multiply it by their respective probability and then add them together. So I take 0 times 0.33 plus 1 times 0.12 plus 2 times 0.28 plus 3 times 0.19 plus 4 times 0.08. So this is 0 plus 0.12 plus 0.56 plus 0.57 plus 0.32. So if I add these all up together, 0.12 plus 0.56 plus 0.57 plus 0.32, I get 1.57. So what this means is the average number of pets in a household is 1.57. And again, the reason that I don't just add up 1, 2, 3, 4 and then divide it by the number of x values that I have is because that does not account for the probability, right? I'm much more likely to have 0 pets than I am to have 4 pets, and so this expected value takes that into account. All right, we have one more lesson today, so go on over to lesson 39, and I'll see you there.